经连进去了，但不晓得 C 豆他看他什么时候要连进来。然后我就是现在是有直播的状态嘛？
对，有直播。
OK。然后可能再看他如果有简报的话，也可以先传过来，然后
我有问他。
好 ，OK。那我有都在线上。
就是最近有新闻，就是联络，就是跟一些其实体验的成员讲，就是如果你平常看到一些好的文章或资讯来源的话，可以帮我分享在那个体验的 TG 群组。对，就是如果有看到，对，他们说，因为蛮多人反映是说他们找不到那种好的资讯来源，希望就是已经是就是大老师等级的各位可以就是帮忙放一点资讯在里面。对，谢谢。
好 ，OK。
就是
蛮多
蛮多人在。
对对对对对。
我好像跳出来了，我再进去一次。你那边看得到吗？刚才那个直播那边。
直播
可以
这边看到就是 Meet 的画面吗？
就是看到我这个画面有看到吗？
我现在还是看到是 Meet 的画面。
Meet， 很像哦。
不好意思，我再刷新一次。
好。
应该还是 Meet 的画面。
就看到我的人头嘛。
对，看到
OK， 好。像几次 DevCon 这样参加人数有到5000人，看起来人好多哦，超级多的。有上来吗？有回吗？还有。
有，他有那个是
OK，
那个
好。
我已经把简报share到。
那我就等他上来，对不对？OK， 好。我想说来的话测试一下。进来了，好，要不要跟他讲一下
Hello.
Hey,
Hi. How are you?
I'm fine.
Hi.
你要开
Okay,
我
hello.
会开一个镜头。Hello.
Hello.
Nice to meet
This is
you.
the
Hi.
organizer.
Yeah, hi. This is John. Nice to meet you.
Nice to meet you.
Hi.
Yeah.
What's your name?
John.
Okay, I'm Cedar.
Nice to
Yeah.
meet you.
Nice to meet
Okay.
you.
So maybe later we will maybe using your slide you can share your screen, and at the same time
Yeah.
we will project this
Okay.
screen to projector, and
Okay.
then
Yeah.
maybe your sound will go through the microphone, and then talk to the.
Okay.
We are in a classroom, so maybe you can see them, but they are here. Yeah.
Okay. Do
Okay.
you want me to try it now?
Yeah, okay. Maybe we can try right now.
Yeah, I can help you to see if they have any questions. So.
Yeah, it will be great. Thank you very much.
Yeah, you're welcome.
because I'm not very good at understanding questions. And,
Yeah.
I'm not a good
Yeah,
English
yeah.
speaker.
Yeah, I can help you.
Thank you very much.
Yeah, and
Um,
also thank you.
mhm.
Oh,
Do you see my screen?
yeah, but we're still like trying the projector if it works.
Okay.
Yeah.
咦，等一下哦。Hello，找他过来弄一下。
好。
So let me know when I have to share my screen.
Okay, sure. He's
What time is
asking-
it there?
He's asking for help.
Okay, no problem.
Yeah, because we rent the place from another organization.
Ah,
Yeah.
okay.
Hello，喂，诶，没有声音。
有开始。
有开了。还是没电。
应该不会。再帮我。有
应该有。
调1跟3个的钮可以调音量。
现在大声一点也可以。
对，调上面那个。
这个。
对。再试试看。
Can you say something?
然后这个好像奇怪，我刚插上去。没有。
Yeah, we are trying the voice.
Ah, okay,
Yeah.
okay, yeah.
用啊。
Hey, hey.
Hey.
Okay.
Okay, good. Thank you.
Okay, now we can see you right now.
Yeah, we can see you. Can you share?
Okay, great.
Yeah.
So,
Can you
yeah.
share your screen?
Wait. Mm-hmm.
OBS 是要把那个关掉，因为 Meet 已经有声音了，但是这样可能会听到现场。
Yeah, it works.
Okay, can you see it?
Yeah.
Okay.
Oh.
所以现场有要收音吗？
现场不收音，我到 Q&A 会听不到，所以变成要考虑一下要收哪边。我想一下。
或是如果用麦克风就收现场就好，因为就是电脑用麦克风，然后如果有问题用麦克风。
对，确定一下，
要叫他说些话。
对，应该是还好。
这样 ，OK。好 ，OK。
因为现在这边是那我不是这个，他是用那个因为你有直播，我觉得应该大家看直播就好。啊？对，我说等一下要开的时候，要讲的时候再开啊。呀，OK。
11月17，
Hello. We will start at 5 minutes later.
Okay.
Yeah, okay. Thank you.
Sorry, can I start now?
Maybe 5 minutes later. Yeah.
Okay, okay.
Yeah.
No problem.
好。
不好意思，因为我在想，我可能那个写的时候，大家以为今天可以是线上对，所以，但是我们讲师因为他是从国外联系的，对，maybe 不能等他太久，对，所以就等下7:05就会开始。那我马上做线上会议，那到时候大家还是可以在现场看这样。然后顺便我提一下，就是说最近就是平方募资这边，我们现在这个投票还在征白名单，好，然后我们应该征到一个程度，我们就开始会开放团队这边进来，然后进来白名单，然后投票系统就会开放。那实际上时间我到时候会在统计，因为白名单目前还在征啊，就是说希望比较多的社群的人进来投，而不是说团队投这样子，那现在还在征这样子。然后还有一个就是最近有一个那个区块链爱好者协会他们办的也是平方募资的一个投票，然后是在11月中吧。但那个我觉得比较是那种纯粹是就是要去上台去讲，然后去表演的。那所以说变成是如果有兴趣的团队想要参加这个的话，也可以跟我讲，然后我就把报名链接传给你们，然后你们也可以去有兴趣也可以参加一下。OK， 好，那是截止吗？它是明天截止，明天对，所以可能要已经报了，先报了。好，那这样的话我们就再等一下下，好，那我们就等下就请那个 C 狗开始。那但是 B 面要不要先介绍一下今天讲的？
今天讲的也是 TSC team 的同事这样，然后他是主要做 Semaphore。都没有。喂。确实好像没什么。哎有。有啊。喂。没有很大声。
这样子。
喂。哦。喂。
好。
好，就是对今天的讲师就是他叫 Cedor， 然后其实本名是欧玛，不过就叫 Cedor 这样。然后他也是 TSC team 的成员，然后他主要是做 Semaphore 跟之前我介绍的那个 Interreg， 可是最近好像就是最近 Interreg 好像要被另外一个 project 叫 ZK Group 取代，然后所以他今天也会讲解一下这个 ZK Group 是怎么回事这样。对，然后对他真的，我觉得他是蛮有经验的工程师啦，所以如果有什么问题都可以 就是尽量问这样。
但是他现在，如果不透过这个的话，好像没办法，他那个应该会转，还是要麦克风，没有人反映说直播的时候会不会有两个人？
我分析是还好
啊，
对。
好，那就先这样。麦克风关起来。那我们要不要直接开始？
Hello.
Hey,
Yeah, I think we can start now. Thank you.
thank you. So, well, hi, I'm Cedar, and I'm from Italy, and I work as a software engineer with the privacy and scaling explorations team. And I have been mainly working on Semaphore for the past 5 months, I guess. And I'm going to talk about anonymous signaling on Ethereum. So why we need anonymity and how we can achieve it. So I would like to start with an important question. Why is anonymity important? I don't know why people are so keen to put the details of their private life in public. They forget that invisibility is a superpower. But we cannot be sure if this quote is from Banksy, but even if it was anonymous, the message is still very important. So invisibility or anonymity is a superpower because it uncouples an idea from the identity of its author, because it allows flower to be thrown without the identity of the flower being known. So although ideas are intrinsically connected to their author, sometimes the message is more important than the messenger. And sometimes preserving the identity of the messenger is even more important. So anonymity can therefore become an important tool because it limits power. Those with a lot of power derive much of that power from knowledge, from information. The more someone knows about us, the more power they can have over us. So keeping our data or our identity private decentralizes that power. Anonymity can also promote freedom of speech. The first step in censoring an idea is to attack its author. And the fear of suffering repercussions for what we say or write also limits our thinking. So knowing that our data and identity are safe encourages us to think freely. Anonymity safeguards reputation. It is important that people are held accountable for their actions and especially for their mistakes, particularly when these people have a lot of responsibility. But it is also important that our ideas are not judged based on who we are, but rather on what we have to say. So anonymity allows an idea to be shared regardless of its author's reputation, which allows people to consider and evaluate ideas from a more objective perspective. So most of us are aware of the importance of anonymity and privacy. But what about our challenges? What are the main drawbacks right now and how we can solve them? There are probably many more reasons, but 2 of them, in my opinion, deserve particular attention. The first one is complexity of technology. In recent years, we have seen a constant growth in the development and use of cryptographic technologies. Zero-knowledge proofs, for example, are now being used in many applications. So proving you have a certain information without revealing that information is a really powerful concept. but the way these technologies work is not trivial for people without a background in mathematics or cryptography. In addition, the availability of simple and practical development tools is still limited. A lot of progress has been made actually, but I believe one more step is needed in order to further abstract some technical concepts. The second drawback is the indifference of people. One of the reasons why some people don't care enough about privacy might be that there is not enough awareness and education about how our data is used and why anonymity is important in a healthy society. So, what can we do then? I would like to focus on 3 solutions. The first one is privacy by default. The right to privacy is mentioned in most national constitutions, but it has often been neglected in the name of national security issues or to make the applications we use every day smarter and more efficient. Privacy and cryptography should be the backbone of the internet infrastructure. Protocols and applications should protect all user data by default. And in addition, users should be free to change those settings, not the opposite. So, the second point is education. Explaining to people why privacy is important and how we can build privacy-focused applications are very valuable challenges. It is important to choose the right words, build effective designs, and convey information as simply as possible. However, simplifying things is not enough. Making people aware of the technological and social complexity of the world we live in is equally important, because we don't just want users to enjoy an experience. We want new friends helping us build a new Web3. The third point is developer experience. The growth of a community and the adoption of a technology depend heavily on how clear the goals are and how easily the main values and concepts can be conveyed. However, another extremely important aspect is the quality of the code. The code should be tested, documented, and formatted with the utmost care. It is extremely important to use the right patterns and to follow the best practices like dry and keys. So developers need to be able to rely on robust, easy-to-use tools that allow applications to be built in a short time, while also allowing them to be extended, customized, and adapted for case-specific uses. So, developer experience and education is what we have focused on in the last few months of work with Semaphore. But many of you may be wondering what Semaphore is. Semaphore is a zero-knowledge protocol that lets users to prove their membership in a group and send signals such as votes or endorsements without revealing their identity. So, yeah. In addition, it also provides a mechanism to prevent double signaling, which basically means you cannot create the same proof twice. What makes Semaphore a powerful tool is the simplicity of the protocol and the flexibility. It can be used to build main applications like private voting applications, whistleblower applications, or zero-knowledge DAOs. And it is made of 3 different parts, CECOM circuits, Solidity contracts, and JavaScript libraries. So my work has focused more on JavaScript libraries and Solidity contracts, but I will also show you how the Semaphore circuits work, which is very important to understand how the protocol works in detail. So let's start with the main concepts. So the first concept is identity, or identities. Creating a Semaphore identity is the first step to interact with the protocol. Each identity is made up of 2 secret values, tractor and nullifier, and 1 public value, commitment. The Poseidon hash of the identity nullifier and tractor is called the identity secret, and its hash is the identity commitment. Although in this case, we are not using asymmetric encryption, an identity commitment is more or less like an Ethereum address. It is a public value used to represent people in the protocol. In particular, commitments are used in Semaphore groups to represent the identity of a group member. The secret values are like Ethereum private keys, and they are used to generate semaphore zero-knowledge proofs and authenticate signals. For each main concept, we have a JavaScript library that can be used by developers. And in this case, we have this library, Semaphore Protocol Identity. And it can be used to create identities off-chain. And there are many ways to create identities. You can create random identities, which is like creating an Ethereum account. So you can create a random identity without passing any parameter to the class. Or you can create a deterministic identity by passing a secret message as a first parameter of the class. And this can be very useful if you want to use, for example, if you want to use a signed message, maybe you can use your MetaMask account, and you can use your Ethereum private key to sign a message, and you could use that message to create an identity. And every time you want to create the same identity, you can sign that message again. It is useful when you want to avoid storing your identity, because you can create it every time you want with your Ethereum account. Another interesting feature is this function, identity.toString, which can be used to export your reputation so that you can use it later to create another reputation based on something you already created before. So, groups are another important concept when we speak about privacy and zero-knowledge technologies. They can be thought as anonymity sets, and are a way to establish necessary trust among participants. So in Semaphore, a group can be many things. They might be people who have an account on some Web2 platform with high reputation, or a group can be a set of employees of a specific company, or voters in an election, or people with specific SBTs or NFTs, or with a specific amount of ethers on chain. And essentially any set of individuals who are eligible to participate in something. So groups can use several types of data structure, but Merkle trees are particularly efficient since they can prove that a leaf belongs to a tree by simply using one portion of that tree. Semaphore uses binary Merkle trees, in which the leaves are the identity commitments of the identities, and all the other nodes in the tree are hashes of their two child nodes. So, in particular, Semaphore uses incremental binary Merkle trees, and the leaves are added incrementally, which means that each new leaf has the index of the previous leaf plus one. Proofs of membership are composed of the path separating the leaf from the root, and can be verified by sequentially calculating the hashes from the leaf to the root and checking whether the calculated root matches the public root of the tree. We can see an example here. The proof of membership is made of 3 different parameters or values. The first one is the leaf. In this case is identity 2. And then there is a list of sibling nodes, in this case identity 1 and hash 2, and the position of those sibling nodes. So 0 is left and 1 is right. So identity 1 is on the left and hash 2 is on the right. So with this data, you can calculate the hashes and the root, and then match if the root, and then check if the root matches the public root. In this case, the hash of the identity 2 and identity 1 is the hash 1, and once you calculate the hash 1, you can calculate the root with the hash 2. So when a user joins a group, their public identity commitment is added to that group's Merkle tree, which is therefore used to allow users to generate proof of membership and send anonymous signals. So there is a JavaScript library for groups as well, and some for groups can be created in two different ways: off-chain with a JavaScript library, as I said before, and on-chain with a semaphore contract. When a group is very large and is updated very frequently, an off-chain group might be a viable alternative. This solution is cheaper, faster, but tending to be more centralized. On the other hand, if you need correct execution or censorship resistance, groups can also be created on-chain with our contracts. And for each on-chain group, there is an admin, which can be an Ethereum address, a multisig wallet, or just another contract. So, for example, if you want to create a fully decentralized on-chain group, you could create a group and set your contract as admin, which could allow users to join the group only if they own specific SPTs or NFTs. So, after creating their identity and joining a group, users can anonymously prove that they are members of that group and send signals, such as votes, endorsements, or any message. So signals are part of zero-knowledge proof, which must be generated by users, preferably in their own device, as they need to use their private identity or secret values. So it's like client-side encryption in a sense, and in this case, it allows proofs to be generated in a protected environment, so that proofs can then be made public and verified by everyone. So to generate a valid proof, we also need an external nullifier, and the hash of this value and the identity nullifier is the nullifier hash, which can be used to avoid double signaling. Imagine you have a group you are using to vote on some proposals, and you want all members of that group to vote only once. You can use the ID of the group as an external nullifier, and when a user votes the first time, you can save the hash of their identity nullifier and group ID, and afterwards block any double votes by checking if that hash already exists in your contract. So, also in this case, we have a JavaScript library, and well, zero-knowledge proofs must be generated off-chain. Obviously, you can't generate zero-knowledge proofs on-chain because there are private values, and you want to keep them secret. And they can be verified both on-chain and off-chain. And the way you use our verifiers depends on your application. So the point here is very similar to the one we already discussed about groups. So verifying an off-chain proof allows the verifier, so you or your server, to be certain of the validity of the proof. Whereas if you verify a proof on-chain, on the other end, that would allow everyone to consider that proof valid because it's public. So let's talk about our circuits. The semaphore circuit is the most important part of the protocol, and indeed can be considered the protocol itself, I guess. And it can be divided into three parts. Proof of membership, which verifies whether the identity belongs to the Merkle tree, which is our group. And the nullifier, which is used to prevent double signaling. And the signal, which is the anonymous user's value. So a vote or an endorsement or a message. So the identity tractor and nullifier are private, as you can see here, because they are secret values and they must be kept private, of course. The proof of membership parameters are private, the siblings, nodes, and the path indices. They are private because they could be used to find the position of the identity commitment, the index of the identity commitment. And we don't want it because proofs are anonymous. So proofs cannot be linked to identity commitments or identities. The The other parameters are public. So the Merkle root is public because anyone should be able to see which group the proof refers to. And anyone should also be able to see which external nullifier has been used to generate the nullifier hash, which has to be saved in a contract, for example. And of course, the signal is public and anonymous because the proof is anonymous. There is no link between identities and proof. So let's talk about the specific components. The first component is about proof of membership, and in this case, the Poseidon hash of the identity secrets, so the identity trapdoor and nullifier, is the identity secret, and the hash of the identity secret is the identity commitment, which is also a leaf of the Merkle tree. So now the Merkle tree verifier can use the other private inputs, so the sibling nodes and the path images, and it can verify if the identity commitment, which is a leaf of the tree, is really part of that tree. So imagine you have a list of public roots related to your groups on chain, for example, and if the calculated root matches the public input, whoever is generating the proof is definitely a member of the group related to that Merkle tree with that specific root. So this component is quite simple. It hashes the identity nullifier and the external nullifier and returns a public nullifier hash that can be used to mark a proof as already verified. So the main point is, in fact, to prevent the exact same proof generated by someone, which at some point becomes public, from being reused by others. So once you generate your proof, that proof cannot be used by anyone else. That's the main reason we have the nullifiers. So the signal could be a user's vote, for example, as I said before, an endorsement or the hash of some data, and it is anonymous because the proof cannot be linked to any identity commitment. This is a simple technique. I mean, that square is a simple technique that can be used to make a public signal unchangeable. Basically, it's a good practice that Circom recommends to prevent tampering. So if that signal is used in a simple constraint, like a dummy square, like in this case, it cannot be updated by any attackers without making the proof invalid. So let's talk about our contracts. Semaphore includes 3 types of contracts. Verifiers, which are used to verify proofs, and there is one verifier for each supported Merkle tree DAT. The base contracts, so semaphore groups, which provides all the functions to create groups or Merkle trees on chain. So it also allows to manage groups, so to add, remove, or update members. And semaphore core, which provides a simple function to verify proofs using the verifiers. And we also have the extension contracts. They extend the protocol to provide application logic for specific use cases. And so those are just some examples, but I think we will add more examples in the future. Semaphore voting, for example, contains the essential functions to create.
Sorry. We have a question.
Oh, yeah.
Yeah.
No problem.
The question is that is the existence of trapdoor be potential target to hacker?
Target to?
Target to hacker.
Oh, well, yeah, based on the hash, you can calculate the original value, but it will be quite difficult. And one of the reasons we have two different values for your identity, for two secret values for your identity, is that they can add an additional security layer. So if some attacker found your trapdoor, they also need to find the other secret value, the nullifier, in order to create a fake proof with your identity.
Yeah, okay, thank you. You can continue.
No problem.
Yeah, thank you.
Thank you. So, but yeah, there are two extension contracts. So the semaphore voting contract and the semaphore whistleblowing contract. The second one is really useful in cases you want to create groups for your company and maybe the employees of your company want to anonymously publish leaks if necessary. Okay, so there is also another contract here, semaphore.sol. It is very important because it can be used by developers and it is already deployed, so developers don't need to create their own contract and inherit the semaphore-based contracts. Semaphore.sol inherits the base contracts for you, and it provides a ready-to-use solution for developers. It also includes a mechanism to prevent double signaling. And yeah, it is available on Goerli and Arbitrum One. So you can see the list of the methods here. You can do everything you want: verify proofs, create groups, add members, update members, remove members. So Semaphore is already being used by some projects like Unirep. Unirep is a protocol or a reputation system built on top of Semaphore, where users can anonymously give, receive, and prove reputation. It is a great way to allow people to build reputation over time while giving them total control over how much they reveal about themselves in a given interaction. Another project is Zkitter, which is an anonymous social network where people can post and chat without losing their real-life reputation. And another example is, another application is the TADS apps. Well, temporary anonymous zone is like an experimental environment where people can use our applications. We used that experiment at DevCon, and it has been really useful because people were be able to try our Semaphore applications. And one application allows you to ask questions and answer questions anonymously, whereas the other application allows you to make art, to draw things anonymously. And yeah, it's like an environment where people can learn more about our protocol, about Semaphore, but zero-knowledge technologies in general. And I think that there will be a version 2, and we will use it in a future event, probably. Another important application is Interrep. I think Vivian already mentioned Interrep, so just an introduction. Interrep is a CB-resistant system that can be used, for example, as a layer to avoid bots or fake accounts in a social network. It provides a set of Semaphore reputation groups that people can join only if they have certain attributes on the supported platforms. Twitter, Reddit, and GitHub. And there are 3 different groups for each provider: gold, silver, and bronze. And for example, if you have a Twitter account and you have more than 7,000 followers, you can join the gold group if the number of followers is lower than 7,000 but greater than 2,000 followers, you can join the silver group. Each group is based on specific thresholds. It consists of a web application that can be used by users to join groups, and a backend, which is the reputation service, that Interrap uses to calculate users' reputation and check if they are eligible to join a specific group. The reputation service also provides a set of APIs that developers can use to integrate Interrap into their application. Semaphore is still in its early stage, and some of the ideas for improving it are the following. Ziki Groups, which is an infrastructure to manage groups. The idea is to create a cloud or self-hosted dashboard where people can create and manage many types of groups, like permissioned or permissionless groups. But I will talk about it in the next slide. And we will investigate all zero-knowledge technologies and new proving systems. We will continue improving the developer experience and documentation. And also, we want to create a strong community. And we have many ideas for involving people in our project. So, Ziki Groups is really important. We are working on that now. So I would like to spend some words for this project. Well, Ziki Groups is like an extension of Interrap, and in both cases, the main goal is to provide APIs for developers to enable them to integrate Semaphore groups and build privacy-based applications. The main target audience for both projects are developers. However, Interrap was designed as an anti-Sybil system based on Semaphore reputation groups. And the main audience are Web3 people who intend to use and export Web2 reputation to Web3, to the Web3 or to blockchains. On the other end, the goal of Ziki Groups is even more ambitious. The idea is to offer a more generic layer, generic infrastructure, to allow people to create their own groups, adaptable to many more use cases. So the audience can also be governments, international institutions, non-profit organizations, or associations. So Ziki Groups also provides an infrastructure that can be used as a cloud service, or it can also be self-hosted, whereas Interrap is just a cloud service. And it adds some architecture components, like the dashboard, which can be used to create and manage groups. And it allows developers to create many kinds of groups, not only reputation groups, which can be grouped into two categories: permissioned groups, so where there is just an admin who decide who to add and who to add a group and how, and permissionless groups where users can join groups themselves based on certain criteria or attributes they have. Also, reputation groups, in particular, in Ziki Groups, can be created by developers who can choose their own reputation thresholds. So in Interrap, we have fixed reputation thresholds. So you have to have more than 7,000 followers on Twitter, etc. Whereas here, developers can choose their own reputation thresholds. And this is quite interesting. Okay, so yeah, that's all. Thank you all for listening. And there are some links. You can scan the QR code on the left to join our Semaphore Discord, and you can visit our website on the right. Thank you very much. Do you have any question? Thank you.
Is there any questions?
Can you hear the question?
No. I can't hear anything.
Hi, Isidore, can you hear me?
Yeah.
Yeah. Because what I'm asking is not very technical, but I'm just curious about why is because the identity is combined by the trapdoor and the nullifier, right? I'm just curious why the naming trapdoor means and what's the idea, because I don't quite get what does it mean calling it a trapdoor.
So is your question about why we are using two values and those values?
But also a naming, but because I'm just wondering that if I know why it's called a trapdoor, and then I can know more why,
Okay.
what's the meaning and what it stands for in the system.
Okay. Well, trapdoor, I think it's a cryptographic name, a common name that is used in the cryptographic environment, but I'm not quite sure. And it is used when you have a function that cannot be inverted. I mean, it's a function where the output cannot be used to obtain the input, the original value. So it's, in this case, we have an hash function, and it's perfect because you can't use the output of your hash to obtain the original value. I'm not quite sure because I'm not a cryptographer.
I see. Because I need to leak like both trapdoor and nullifier to leak the identity. Is that correct? So then
Yeah.
they can like forge any kind of proof.
Yep, you need both of them.
Okay, I see. Thank you.
No problem.
Hi, Theo. Can you hear me?
Yeah.
Yeah, I would like to know what is good practice to manage a group, because I think in this project we need someone or the owner to add a member and delete a member. So is any a method to make it more decentralized, or the manager can be, or the owner can be owned by the group instead of one owner?
Do you mean the on-chain groups?
On-chain group, it may be like if I have a group and the group has some members, so if we want to add one more member, the ownership is, the add member is controlled by those those members instead of one member.
Yeah. Well, there are two kind of groups, on-chain and off-chain groups.
Yeah.
And when you create your on-chain group, you need to pass an address that can also be your contract address. And in that case, the group will be decentralized because in your contract, you can create any function you want to, well, you could allow everyone to join your group because the contract address is the admin. And if that contract has a specific function which is open and public, everyone can use that function to join your group. And usually when you use that kind of function, when you have a contract address as an admin, you want to allow people to join your group only if they have certain attributes in that case, on-chain attributes. So, for example, NFTs or SBTs. And yeah, in that case, you can create a fully decentralized group because the admin is your contract, and your contract can allow everyone to join your group based on certain on-chain attributes.
Okay, got it. So I have another question is about the ZK group. So in your plan, how does those how to verify address can be added to the group? Like if I have 100 followers on Twitter, so is the infrastructure will help me to verify the off-chain data and submit to the on-chain and make the address into the group?
Yeah, yeah. You're talking about reputation groups, and in that case, you need a server
Yeah.
that must be used to check if the user has the right. Well, first of all, it must check whether the user is a real user or not, if they have the right Twitter account, for example. And after that, they need to check, that server must check if that user has the right reputation thresholds in order to allow them to join that group. Without that backend check, anyone could join that group. So we need it. It is necessary to have a server and a backend check for that.
Yeah, it's possible to make the rule developed or defined by users instead of the infrastructure.
Can you repeat, sorry?
Yeah, because in the previous question is means the rule should be defined in the infrastructure. So the infrastructure will help me to check if the user have enough followers. So I just think if we can make the infrastructure more programmable, so user can plug some scripts into the infrastructure, and it can help everyone to define their own rules to check the off-chain data and make their own rule.
Are you asking me if users can decide the right threshold for them?
Yeah.
Okay. Well, yeah, that could be a cool idea actually. In ZK groups, developers can choose the right thresholds for each group, but that could be an interesting future, a future where users can choose the right thresholds for themselves. Yeah, definitely. But also in this case, you need a backend check, right?
Yeah, I got it. Okay, thank you.
Thank you.
Another question is that when a member sends signals through semaphore, the message is private, right?
It is public. When you create a proof, the only private parameters are your secret values, so the trapdoor and the nullifier, and the proof of membership values, so the sibling nodes and the path indices. All the other proof inputs and outputs are public, so your signal is public, but it is anonymous, so no one can understand the link between your signal and your identity.
Okay, thank you.
No problem. Thank you.
Yeah, we don't have any questions. Yeah.
Okay, thank you very much.
Thank you. Thank you for joining with us today. Yeah.
Thank you. I really appreciated your invitation and I really enjoyed it.
Thank you.
Thank you all. Bye bye.
Bye.
就讲那如果也有其他的应该这边的话也可以问嘛，对不对？如果有问题要问